Okay, the next thing is a graphing assignment. Okay, it's pretty interesting. Well, not interesting, but I want you to graph this function here. Remember, this is the x, this is the y. It just says y is equal to the square root of x. So make a table here. And what you're going to do is put numbers in for x that are actually show up as perfect square roots. Actually, you never notice, but the square root of 0 is actually a perfect square, okay? Because that'd be 0. So we're going to actually start with 0. And we can't go that way because you can't have negatives in a square root. Because watch what happens when I put a negative in a square root. Domain error, okay? Yeah, domain error, so you can't put negatives. It starts at 0, and then we'll go 1, 4, 9, okay? And we could keep going, so make continuation dots. Now to find the y, it's really easy. If I would put 0 in that square root, what's the square root of 0? 0. If I put 1 in the square root, what's the square root of 1? 1. If I put 4 in the square root, what's the square root of 4? 2. If I put 9 in, what's the square root of 9? 9's going to be 3, okay? And that could keep going, because I could keep going. You could also be putting numbers in between, okay? They'd just be decimals. So I go second. Don't put this, but I'm just showing you. You could put 3 in, okay? I mean, it would work. You just get that, which isn't a whole lot of fun when you're graphing, okay? So let's just stick with that. It's a continuous graph, so these points will be connected. So you got 0, 0, that's the middle, okay? So 1, 1, that's forward 1, up 1. And then connect them. 4, 2, 1, 2, 3, 4, 1, 2. Again, connect them, because you could put those into square roots. They'd just be decimals. Okay, then 9, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. Okay, there you are. Now tear off this paper, because you are going to use this to set up, this table sets up everything. This table is known as your parent graph, okay? Parent graph. Okay, so when I see that x, the independent variables inside of a radical, and I have to graph it, I set up my table for the parent graph first before I worry about anything else. So 0, 1, 4, 9. And then the y outputs would be 0, 1, 2, 3. Now, here's my question. Is that plus 1 inside the radical with x, or is it outside the radical? Well, it's outside the radical. Since it's outside, you do the operation to all of your y's, okay? And here I'll put this outside. You do it to y, okay? Inside, you do it to x, but x also has a special rule. But this is outside, so we'll add 1 to all the y's. So I'll add 1 to every one of these y values. So that's 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. Okay, so you're going to graph that, and don't worry about identifying the domain and range, okay? That's for later, okay? So you got 0 with 1, that's your first point. So 0 up 1. Now, can you please do me a favor and label this first point? Just put 0, comma 1. Just that point. That's the only point I need you to do it for. 1, 2. So I go forward 1, up 1, 2. And then connect. 4, 3. Go forward 1, 2, 3, 4, up 1, 2, 3. Then 9, 4. Okay. And connect. Okay. That's the graph. Only an arrow comes off this side, okay? Because you can keep going that way, but you can't go beyond this, because putting beyond 0 this way would be negatives. You can't put negatives in square roots. So when you make that 0, comma 1, you don't put an arrow on that side. Okay, now our next one. So again, start off with your parent function, input 0, 1, 4, 9, and you can keep going. You can go 16, 25, 36, go on forever. And the y's give you 0, 1, 2, 3. Okay, so again, is this inside or outside? It's outside, okay? So if it's outside, you do that operation to all of your y's. Leave your x's alone. So 0 minus 2 is negative 2, 1 minus 2 is negative 1, 2 minus 2 is 0, and 3 minus 2 is 1. Okay, so 0, negative 2. Okay, so 0 means I stay in the middle, but I go down 2 instead of up. So 0, comma, negative 2. Just label that point. That's the only point I need you to label. That's for the next part of this. 1, negative 1. Okay, so I go forward 1, up 1. Or forward 1, down 1, my bad. 4, 0. 1, 2, 3, 4. Okay, then 9, 1. 1, 2, 3, 4, 5, 6, 7. Okay, there you have it. Okay, now on my next problem, I set up my parent, and then the result, 0, 1, 2, 3. But this time the operation of minus 3 is inside, okay? That minus 3 is inside. Now, with inside, you do it for x, you do it to the x side of the thing. But here's a kicker. When it's inside, you do the opposite of what's happening to x, okay? It's not like it's outside, you just do the same operation. Here I saw plus 1, so that's what I did. Here I saw minus 1, that's what I did. When I see it inside, I need to do the opposite of minus 3, which is plus 3. 0 plus 3 is 3. Now here's why I did that, or I'll show you why I'm doing that, I have to do opposite to the x's here in a bit. 4 plus 3 is 7, 9 plus 3 is 12. Here's why. If you put 3 in, what's 3 minus 3? That'd be 0, takes you back to the parent. 4 minus 3 is 1, takes you back to the parent. 7 minus 3 is 4, takes it back to the parent. 12 minus 3 is 9, takes it back to the original parent. So, now you graph them, so 3, 0. 4, 1. 1, 2, 3, 4. Up 1. And by the way, label that first point, because for the next part of your video, you're going to do that. So 3, 0. 7, 2. Whoops, that was poor. Sorry, my bad. If you go the wrong way, just flip it. 12, 3. 12, 3 is off the graph, so I'm not going to graph it. I'm just going to go like this, okay? Remember, please make sure you have labeled that first point. Okay, and then the last one before I let you work on the 4 problems. Make your parent graph, okay? So you got 0, 1, 4, 9. And then 0, 1, 2, 3. Now we see a plus 6. Is it inside the radical or outside? That's inside. So you do it to the x, and it's got to be the opposite. Okay? Outside's not the opposite. It's to the y, but it's not the opposite. Inside is. So I'll do the opposite of plus 6, which is minus 6. So if I have 0 minus 6, that's negative 6. 1 minus 6 is negative 5. 4 minus 6 is negative 2. 9 minus 6 is 3. Okay? So negative 6, 0. 1, 2, 3, 4, 5, 6. And please label that very first one, just the very first one. Negative 5, 1. 1, 2, 3, 4, 5, up 1. Okay? Negative 2, 2. So and then 3, 3. Okay, remember you keep going that way, but not this way. Okay, make sure that point is labeled when you're doing this. Okay, do exactly what I just did, okay, on problems 1, 2, 3, 4. Remember, outside's done to y, not the opposite. Inside's done to the x, opposite. Outside, inside, so remember that. Now, in the next part, I'm going to teach you how to identify your domain and range. Here's what you do. You write domain, it's D-O-M-A-I-N, and then range, R-A-N-G-E. The domain is related to your x, the range is related to your y. Now, here's what you do for your domain. That point, the 0, 1, okay? That's x, that's y. Put 0 across from x, put 1 across from y. Now, here's my question, okay? You need to put greater than or less than signs in between those. That's how a domain and range is identified, okay? Here's how you do the x. You make a straight vertical line, okay, like I am. Do all your points go to the right or the left of that? To the right, correct? So I use the greater than sign. So I just make a line through that point, that first point, line right through it, a vertical line. Now to find your range, you make a horizontal line through that very first point. Now, are all the points above, all your points above that line or below? Look like they're above it, okay? Since they're above it, it's greater than or equal to. Okay, let's look at our next graph. Domain, range. Domain is x, range is y. Okay, so the domain is, so the x would be 0 and the range would be -2, okay? But we got to decide if we're greater than or less than, so look at that first point. First, make a straight vertical line through that, okay? Are all the points to the right or to the left? They're to the right, so you use greater than or equal to. Now, draw a straight horizontal line through that. Are all the points above that or below that? They're all above it, so another greater than or equal to. That means in this function, x cannot be has to be greater than or equal to 0, y is greater than or equal to -2. Okay, next one, domain, range. So you put x and y. So again, the domain is the 3 and then 0. Now, which way does it go? So the x, you make a straight, kind of dashed, imaginary. All points are to the right of it. So that's greater than or equal to. Now, make a straight horizontal line. If it goes over the line, that's fine. All points are above that line. So that's greater than or equal to. Okay. Inside, okay? Or right here, same idea. So domain, range. X is the domain, y is the range. Okay, so again, you have -6 for x and 0 for y. So again, with your domain, you make an imaginary kind of vertical line, and if all points are to the right of that, it's greater than or equal to. Now, if all points are on this side, then it's less than, okay? Now your range, okay? Make a straight horizontal line through there like I am with the orange marker. Are all points above or below that line? They're above it, so it'd be greater than or equal to.